Thank you all for coming out and listening to my talk. I'll try to keep this pretty quick so that you're not starving. So today I'm talking about Terraform security attacking and defending IAC. So quick introduction, I'm Mike McCabe, President and CEO of Cloud Security Partners. We help people with clouds. Thank you. All good. All right, good for now. So I'm Mike McCabe, President of Cloud Security Partners. So we do a lot of work in cloud security. A lot of that is around infrastructure as code, which I'll talk about. And as a security person trying to help people be more secure, I'm very passionate about this topic, and I'll get into why that is. So what are we talking about? How many folks are familiar with Terraform? Okay, handful, that's good. So it's infrastructure as code, obviously. It makes your infrastructure codified and consistent. Some of the benefits of that are, we traditionally did things like ClickOps, which is going into a console, creating your EC2, creating your S3 bucket, naming it, Mike123, and then moving on to the next thing. So we have all this kind of spray and pray with infrastructure traditionally. We had people just setting things up without having the right settings. And we moved to an infrastructure as code based deployment because it gives you centralized deployments, so you have one place to do everything versus everyone going into the console and deploying things. You can deploy consistent infrastructure. You're using modules, you're using guardrails to keep things enforced. It's all in code, so that means all of it's in GitHub or Bitbucket or GitLab. If you're zipping files and sending them around, things have gone wrong, but I've seen that more recently than I wish I had, so. And the big thing is you can apply security controls for preventative measures at that level. Some of the challenges, though, with infrastructure as code is Terraform and other pipelines, just like we see with app pipelines, they're given a lot of permissions. If you go and look at your Terraform pipeline or whatever it is, CloudFormation, whatever you're using, and it has the admin access role for AWS, you need to start working on fixing that right now because it shouldn't have that much access, but often people give pipelines more access just so that they can get the job done and not figure out what's the least privileges I need to give it because it just takes a long time to do that. It's admittedly hard to do. Terraform has quite a few ways to do remote code execution, which I'll talk about some of them. It's also a great way to gather data about an environment. Because Terraform is a stateful tool, which I'll get into, it has all the information about what the environment looks like right now. And there's also ways to bypass security controls. So even if you do have security controls in place, there are ways to bypass those to keep doing malicious activities. So our experience in this, we've worked with a lot of large companies moving their infrastructure to a Terraform or CloudFormation-based deployment stack away from the traditional way of doing things, centralizing their deployments in one place so that teams have one tool to adopt to have the kind of company-wide way of doing things. Along with that, we've written thousands of rules, literally thousands of rules across different languages to basically enforce those security guardrails, those compliance rules. And what we see, I do this with our customers pretty regularly, is we'll go into their CSPM, their Wiz.io, their whatever tool you have, it doesn't really matter. We'll look at all of the resources that are deployed through these pipelines, and we'll see almost no findings. You still see some patching issues, you'll see some stuff that happened post-deployment maybe, but from the cloud configuration perspective, we see almost no findings if this is done well. And anyone who has a CSPM tool, that's Cloud Security Posture Management, it's your Wiz or Divi or whatever it is, those usually are lit up with thousands of findings. If you have hundreds of accounts or even dozens of accounts, you have thousands of resources. Each of those resources has 3 to 10 to 30 configurations that are security related. And you can just imagine at scale how many issues you're going to have if you don't have something preventing these kind of issues. So the reason why I'm so passionate about talking about how security people can start using these tools to be more secure and be more just aware of how they work is because you can have such powerful preventative controls. So for anyone who hasn't seen what these pipelines look like, it's very similar to app pipelines. It's not completely different. It's not a different paradigm exactly. On the left side, you have your source code management, GitHub, GitLab, whatever it might be. In this example, I'm using Terraform Cloud, which is just Terraform, HashiCorp's Terraform cloud-based pipeline. They also have an enterprise product, or you can just use Terraform open source. It is a free and open source tool. It's sort of not exactly purely open source now, but it's still free. And then on the right side, you have your cloud providers. You can even have Kubernetes on-prem being deployed through your pipeline. You can do a lot of configuration through Terraform. It doesn't have to just be AWS and Azure or GCP. So, but it's a typical pipeline. It's nothing too out of the ordinary. Devs write code, they push it to the left side, the pipeline picks it up, pushes out the resources to the environment. So it seems like a lot of folks here are already familiar with it, but just to give kind of a high-level overview of how Terraform actually works, because it is important for the security part of how security controls and how malicious actors can bypass them is how the actual fundamentals of Terraform work. So it's a stateful tool, which means we're not just running a command line script to create an EC2. We're running a Terraform plan and apply, which then creates a state file, which says what you just did and what the state is. So how Terraform does that is kind of two steps. You have the Terraform plan, which is you write your Terraform. It can be super simple. You run Terraform plan. It goes out to the cloud provider. It says, what am I doing based on what this person just wrote? Am I creating an EC2? Am I modifying an EC2? It creates that plan, which basically says, before I do, or when I do the next step, this is what's going to happen. It could be a delete, it could be a modify, it could be a create. So that's when it creates the dependency tree. It says, okay, I have to create this KMS key before I can reference it to this S3 bucket. And it tells you basically what you're about to do, which is very important because you definitely want to do an apply and review what you're going to do before you kick it off, because you might just tear down your whole prod environment if you're not paying attention. And a big part of that is it determines unknown values. When it creates that dependency tree, if it doesn't know what a value is because it doesn't exist, think of like ARNs for new resources, you don't know what that ARN is until it's created, so you can't reference that value. It basically puts in placeholders for those values and says, we'll know this once the apply is done and the resource is created. So that's very important from a security perspective, which I'll get into in a little bit. And then the second step is the Terraform apply, which is the actual rubber hitting the road, where it's going to reach out to AWS, whatever cloud provider. It's going to stand up all those different resources. And then lastly, it outputs all of that to the state file. So if you haven't seen Terraform, it's very simple. HashiCorp in their wisdom decided to create their own configuration language versus using YAML or JSON, but there's some benefits to it. It's not a full programming language, it's more of a specification, but you actually can write some logical operators in it to make it a little more flexible. But in this example, very simple piece of Terraform, but this is creating an EC2. So all you need to write is 12 lines of code to create an EC2 in AWS. So you don't have to write hundreds of lines of code. It's not complex at all, and you can run this Terraform plan, Terraform apply, and your EC2 is going to be stood up. The interesting thing is, even though you define very few things in that EC2, Terraform in the back end is defining all of these things. So this is what a Terraform plan looks like once you've run the plan. So it's defining all these different attributes that you didn't define. Some are default, some are null, some are maybe account-specific things, and it's populating all of them even though you didn't say what to do. And here's kind of a zoomed-in version. And so you can see there's already some interesting things on a very basic example of Terraform. You can probably spot one, which is get password data, which is a way to actually get password data out of Windows EC2 instances. So even though we're not defining it, all those things exist, which makes, you have to think about these things from a security perspective. And this is part of the magic of what Terraform does is you don't have to define everything, it'll handle a lot for you, which is a good and a bad thing. But it definitely simplifies things quite a bit. And that last piece is the Terraform state file. So, like I said, when you want to manage something through Terraform, it's not just run Terraform once and then you ignore it for the rest of the existence of those resources. You continuously use your plan files and your state to basically manage the lifecycle of those resources. So if you want to go create an EC2, you write the Terraform, you run Terraform plan and apply, it creates it. When it's time to tear that down, you again use Terraform to do a destroy. It's going to go to that state file, it's going to say what is out there in this state, what am I destroying? And that's pretty impactful for security for a couple reasons. One is it has a map of your entire environment. So if I just had your state file in enough time, I could understand your entire cloud environment, which is pretty important if you're a red teamer or you're a malicious actor. Understanding the entire environment based off of one file, pretty good amount of information. The other thing is it holds secrets. So any secret that you deploy through Terraform, which I wouldn't recommend you do use Terraform to deploy secrets, but a lot of people still do it, and a lot of resources also give you secrets, like RDS, the master password gets printed to the Terraform state, even if you don't set it, because it has to have a master password to basically start. So it's an interesting file for that reason, and here's an example of a AWS Secrets Manager secret. So I created a secret, my secret value, not great. I run a Terraform plan and apply, and that secret ends up in the state file. So if I have, systems passwords, if I have database passwords, whatever it is, and I use Terraform to deploy those values, all that's going to end up in the state file. There's no real great way around that. And so if you're a red teamer, these are great things to go after. Figure out where your state file is. A lot of people use S3 as a backend to hold that state file. Figure out, if you're a blue teamer, figure out what are the permissions on that S3 bucket. Is it public? Is it semi-public to your entire company? Definitely figure out how that's managed, because people spend millions of dollars on secrets management tools, and then they throw them all into Secrets Manager. They throw them all into the state file, which becomes another Secrets Manager. And I think this is, I always say this, I feel very bad for this guy because I've done this talk a bunch of times and called him out each time, but this is a GitHub issue on the Terraform repo from 2014 where someone's basically saying, hey, we have secrets in our state file, how do we prevent that, how do we handle it? So from 2014, we're almost to 2024, so 10 years. This screenshot I took a couple months ago, but this is a PM for HashiCorp being like, yeah, we're working on it, we're aware of this issue, we have no solution for you. So almost 10 years that this has been an issue, and HashiCorp has not done anything to really address it. There's some hacky ways that people try to get around this. The big thing is not using Terraform to deploy secrets, but as I said, it's not possible to completely avoid that. And HashiCorp doesn't have a good solution for you. So basically treat state files like, like the golden ticket to the rest of your environment. Every talk has to have one meme. I'll give you this one. So this is very sad but true. And another kind of aspect of infrastructure as code security is, in the AppSec world, we talk a lot about SBOMs and all the libraries and packages that we use in our applications. In the Terraform infrastructure as code world, it's the exact same thing. This is just a list of some of the providers that HashiCorp gives you. So Terraform is a very basic language on its own. You can't do much with it unless you use a provider like the AWS provider or Azure or whatever it might be. Those are what interface basically between the APIs of your cloud that you're using and Terraform. So those define all those resources, and then Terraform takes those and reaches out to the cloud environment and makes those updates. So all of these are massive code bases. And you're going to be pulling in at least some of these, probably 5 to 10, honestly, in any environment. So yeah, I didn't put any music on, but someone over there put on some music. So someone told them what they wanted to hear. But yeah, all of these are massive code bases. So actually this morning I checked. I pulled down the latest AWS provider, and it's all written in Go. Terraform's all Go. And that's 1.8 million lines, 1.8 million lines of code that you're pulling in. This is the official HashiCorp provider for AWS, so in theory we trust it. It is on GitHub, it does take open source pull requests, and we know how that's kind of gone at times. Someone was telling me yesterday one of their devs got in trouble because they were approving Duo pushes for pull request approvals by tapping their Apple Watch on their forehead because they got so many of them. That's just the reality that we live in. So don't trust the fact that there are pull request approvals on this, that no malicious code will ever get added to this repo. But when you're using Terraform and you're using these providers, you're trusting all of that code. On top of the Terraform code, you're trusting the provider code. And there's a lot of open source providers that, that are not maintained by HashiCorp. Anyone can write one of these. You can write it for whatever API you want and have Terraform manage it. There's a Domino's provider. What are the other good ones? I think a Tesla one. There's a lot of different providers out there, so people write them to use Terraform to manage the configuration. So you're trusting a lot of code when you use these tools. Terraform API. So if you're using open source, you don't have really an API exposed. It's just a binary that runs in your Jenkins or whatever CI that you use. But if you're using something like Terraform Enterprise, which is hosted internally, or Terraform Cloud, or Spacelift, a third-party CI tool for Terraform, they all have APIs that expose all of these actions. So it's one more kind of attack surface we have to think about with infrastructure as code tools. If your API is open to pull your state file out, I can just use that to grab that state file, get those secrets, pivot elsewhere. If I can use the update plan file or update state file action in your API, I can do a lot of damage, basically. So it's one other area to think about when it comes to Terraform is all the APIs that can be exposed as well. Another facet of this is logging. So when Terraform runs, it has to assume a role. Usually, it's assuming the EC2 role that you're running Terraform on to do all the activities it's going to do in the cloud. If it's like EC2, it's going to be an instance profile. And for some reason, they've sort of fixed this now, but for some reason they decided that when it does that assume role, and if you have the TF log variable set high enough, which is just an environmental variable, it will dump out the full credential for that assume role. If anyone's familiar with the cloud, if you have a Terraform role that has something like admin access and you have access to this STS credential, you basically can assume that role from anywhere you want if there's no restrictions on it. So all a dev has to do, or malicious actor has to do, is set this variable to TF log to verbose or trace, and then this gets dumped out. You can then just use that to run whatever you want outside of Terraform. And again, I like HashiCorp's products. I don't love their security. So you can see in the middle they have the access key, which is partially blanked out. And now access keys are not considered secret. People say, or AWS says, don't expose these, but it's not a true secret. With that, you're not going to get anything except for potentially identifying an account. What they didn't blank out is the secret access key and the session token. I have no idea why they chose to do it this way. Because if you have access to CloudTrail and you have access to this log, you can look up both the access key and the secret access key. The only thing that doesn't get logged is the session token. So, like I said, I like HashiCorp's products. Their security has a lot of room to improve. They are, I think, trying with good feedback from folks, but there's still a lot to do. So yeah, with all of that said, I like this image. Hopefully it's big enough to read, but the highlighted part says, for competent persons only, which you have to think about, why did that label get added to that tool? Because that's for testing electrical sockets and lines. But the point with Terraform is it's a really great tool. There's a lot of opportunity for security integration with these types of tools, but you do have to be aware of all the issues that are present or all the kind of threats and attack surface you have with them. And now I'll kind of dive into some of those. So these are only a handful of things that we discovered when we've worked on these projects. Like I said, the Terraform code base is massive, the provider code bases are massive. There's so much more to dig into in this environment. So this is only some things that we have found in lockdown. It's not everything for sure. So I definitely suggest, if you like digging into stuff, figure out how you can use Terraform to gain more access. So one of the first things I'll cover is Terraform is an infrastructure as code management tool. So they make a differentiation between infrastructure as code and endpoint management. So if people are familiar with like Ansible or Chef or Puppet, those are more focused on, okay, I have an EC2, how do I set it up? How do I get my dependencies set up, all the packages I need? They focus on that part, and HashiCorp says Terraform is for the infrastructure part. With that said, they do give you ways to basically run scripts. So you could use Terraform to then run Chef on a server if you wanted to. But what issue does that present is you're now mixing scripting with your Terraform. So if you don't expect your developers to run scripts on your EC2s, but they do have a way via Terraform, you just open up a hole to your environment. So a pretty simple example is you set up an EC2, you have Terraform connect to it, and then run a script post setup. In this case, most people are probably familiar if they can read it, but running netcat to get a reverse shell out of production. So if you're a developer and you don't have production access or some lockdown environment access because you do privileged access management where no one can get into production without like a change ticket or break glass, you can just use Terraform to basically get a shell back out of your production environment or connect from that production server into something else. So it's just one technique that you can use to basically run whatever code you want on the servers that you have in your environment. And it gets tricky when you combine tooling for Terraform and tooling for code, because it's two different concerns, two different issues, two different tooling sets, really. Another example, remote exec will run on your EC2 that you set up. Local exec runs where Terraform runs. Like I said, Terraform has to assume a role to do anything. Terraform without access to your environment can't really do much. So if you have access to the box where Terraform is running, that means that you can do whatever you want along with whatever Terraform does. So if it's on an EC2 that has a high privilege role, you can run local exec to get that role or dump out the credentials or do whatever you really want to do. It's another built-in functionality of Terraform. So in this example, we're running local exec. We're curling the metadata endpoint. If you're familiar with AWS, the metadata endpoint is what EC2s use to basically get that temporary credential. Dumping it out to a file and then getting it out of the environment, curling it out of the environment to use elsewhere. So basically, if you're a malicious actor, you have access to a developer machine, you write some Terraform, you push it up to the pipeline runs it, and you just dumped out a highly privileged role that you can use elsewhere. So it's a pretty effective way to bypass a lot of controls to get access to things that would be much harder to do without more privileged access. And sadly, phishing still works. Getting people to click on links and download things still works. So this is a pretty real attack vector if you're going after developers who have access to production pipelines. So how do we prevent some of these things? I think a lot of people are probably familiar with semgrep if you do AppSec, but if you're not, semgrep is an open source tool that it's semantic grep, which basically means it builds on the pattern matching of grep to give you more flexibility, more logic. You can add metadata to it, you can have variables in it. But it's a really simple tool overall because if anyone's done AppSec for a while, you've struggled with check marks or Veracode or hopefully not Fortify, but there's probably someone in the room who's had to deal with Fortify on a daily basis. I'm sorry. But we've had these heavy static analysis tools, and they're just not a good fit for fast pipelines where people are trying to deploy every day, every few hours. So tools like semgrep are great because we're looking for very basic patterns with this kind of issue. We're not looking for complex multi-file types of issues. These are single variable, single provisioners we're looking for. So we don't need complex rules to prevent some of these things. So if you introduce semgrep into your environment, if you have pipelines that run something like TerraGrunt to do unit testing for your Terraform, and then you can add semgrep as an additional layer. And we actually push some rules to the semgrep registry for these provisioners. So if you just use their Terraform rules, you'll get these prevented in your pipeline. So you don't have to introduce a huge outside of the normal pipeline security solution to prevent a lot of these issues. That's the great thing about it. There's a paid version, but you can just use the open source version and get this for free. So the great thing about Terraform is it is a relatively simple language. There's definitely complexities. There's definitely complexities when it comes to modules and how certain variables get hidden when you're doing references and things like that. But there's so many easy solutions to use with this type of language because it is a specification-driven language versus a Ruby or or Python or Java, where there's much more abstraction, much more complication. Another thing Terraform is great for is gathering data. So, like I said, the state file is a huge source of information about your environment. Definitely go after that if you're doing testing for clients or for your own company. But there's other ways that Terraform can access your environment. So you have to think about it. Anything that Terraform can manage in your environment, update, create, destroy, it can also have access to read. So any secrets management secrets, any SSM parameters, any password data that can be harvested, that's all available through Terraform. And there's some built-in interesting functions that they give you that, again, they're not just pure infrastructure as code tools. They're kind of hacks built into Terraform to give you an ability to do other things. So there's not a really in-depth provider for HTTP web calls. There's no like curl for Terraform, but they do give you this HTTP data call. And in Terraform, there's data resources and there's managed resources. Managed resources are your EC2s, your RDS, the actual cloud resources. Data is something that you reference. It could be a static file, it could be like a JSON document for a role, or in this case, we're actually calling the metadata instance to use as a data reference. So again, we can use a built-in technique to run this Terraform, have it dump out the STS role. This will get output in the pipeline logs, and you can go use that to get access to the environment. So that's what this would look like. Again, if you have admin access assigned to your Terraform pipeline, you're going to be giving someone admin access to it if they run this type of script. So again, the great thing about this is these are very simple things to solve for. You don't need Fortify or check marks or whatever. You need a very simple solution. You could get away with grep. You could get away with awk. Like, you don't need a lot. If you use PowerShell, I don't know what you need, but probably a switch of tools. But you don't have to have a hugely complex pipeline or security tool to fix these issues. You can just write basic semgrep for all of this. The one thing I'll say is that semgrep, the current policy set, except for the ones that we've written, they don't think about the malicious use cases, they just think about the misconfiguration use cases. So some of these you'll have to write yourself, but again, they're very simple. So another built-in functionality of Terraform is something called external data. Again, they have all these weird little wrappers built into Terraform that, this isn't meant for just setting up your EC2. This is for running scripts. In this case, we're running a Python script where you can run bash, you can run just inline scripts. And there are all these kind of hidden features of Terraform that can really bite you if you don't realize that they're out there and give people privileged access to your environment. So in this case, we're running external data, which is, again, just running a script. It's a data call, but it's just running a script. And so we're running a Python script. In the query, we're referencing a data call, which is to a secrets manager secret. So we're pulling in a secrets manager secret and then passing that to the Python, and then that can be exfilled out of the environment. So again, anything that Terraform has access to, you can pull that out and then exfil that out of the environment and use it elsewhere. So semgrep is great. It's a really good tool for AppSec and for things like Terraform. But if you want to do compliance as code, if you want to do more in-depth logic for your infrastructure as code, there's other solutions that give you a little more in-depth tooling. They give you more logic than those basic tools. A couple that we've used are HashiCorp Sentinel, which is a paid tool. I'm not shilling for HashiCorp. I usually insult them more than I promote them, but they do have a tool that they created for this use case. And then OPA Rego, which is an open source tool from the Open Policy Agent folks. Rego is a whole language. It's kind of interesting and weird, but you can use it for AppSec stuff, you can use it for IAM policies, pretty much anything that you can write tests for, you can use Rego to do validation on security rules. So we've done a lot of work with Sentinel, which is another homegrown language from HashiCorp. They just love doing their own thing versus using all the tools that are already out there. But it's still a pretty simple language. You can define variables, you can define functions, so you can do everything you can really do with a normal language. So in this case, we have 16 lines of code that what we're doing is we're grabbing all the EC2s from the plan file. We're creating a list of allowed types of EC2s, and we're just doing a filter on what is not in this allowed list. So in 12 or 16 lines of code, you basically have a way to prevent people from using certain EC2 sizes. That's a really basic example. That's not hugely security impactful, but the point is, again, what I like about these tools is you don't have to write thousands of lines of code to get this in your environment to prevent these things. If you write one semgrep rule or one sentinel rule that prevents S3 from being public, you're probably going to prevent an eventual breach, because everyone has an S3 bucket that's public at some point. So that's what's great about these tools is they're not complex. This is a slightly more complex version, but this is basically saying what role can Terraform assume. If you have a defined role, you don't want it to go assume your DevOps role or something like that, or your break glass role. So again, these are really simple rules. So I touched on this at the beginning, but after unknowns are an interesting edge case with Terraform because, like I said, there's certain values that aren't known until the plan is run. You can't know what the ARN value is for a resource if that resource doesn't exist. But if you write a rule to say, I want to use this KMS key, it has to be defined on my S3 bucket, but that KMS key doesn't exist. How do you write a rule to enforce something that doesn't exist? So this is where you get into an edge case where these values become after an unknown, and that kind of code sample is from a plan file where all of these values go in the after an unknown block, and if you write a sentinel rule or semgrep rule that looks for a basic match for something like KMS key equals this, or look for the presence of public being true, if you don't have logic built into your rules, you can bypass all your rules. And this is an issue that we discovered and brought it to HashiCorp, and they don't really have a solution. So we basically had to write code to explicitly validate when something is after unknown and not allow it. So if you were an attacker and you wanted to bypass these rules, you have to force the values that you're trying to bypass to be after unknown. And that's not as hard as it sounds. If you use something like operational, like conditionals in your Terraform, you can make these after unknown. So make it after unknown, the sentinel rule will pass, you can make an S3 bucket public, you can make something unencrypted, you can do whatever you want. So this is a pretty big issue when it comes to Terraform because it's just a built-in functionality of how it works. So you have to have those explicit checks for after unknowns. So those are a lot of the issues that we've seen in these environments and some of the safeguards that we've also built out. But to solve these issues, you really have to have layers of defense. You can't just have one, you can't just have semgrep and call it done. You have to think about how you build these pipelines, how you use Terraform, how you use cloud overall to have a really good program for defending against attacks with these pipelines. So, some of the things are, IEM is of course kind of your first line of defense. Patterns is a huge part, code review obviously. But kind of the first one is, the great thing about cloud environments, especially AWS in my opinion, IEM is such a powerful tool for security issues because you can write very fine-grained policies to say, this principal can do this at this time with these conditions being met. You can prevent a lot of these issues. If you have a Terraform role that can't be run outside of your VPC or your org, you prevent someone from assuming that role if they do get access to the SDS credential. So build those guardrails for how your IAM roles can be used, especially your privileged ones. And always build your policies to be least privileged. Again, that's really difficult to do. It takes a lot of time, but it can be done. You just have to kind of do it incrementally and build out those policies so that you give least privilege to your pipelines. And the big thing is monitoring changes. If people are changing your Terraform role or whatever pipeline role you have, if it's constantly happening, things are probably going wrong. Or if you see a brand new set of policies being added, something is probably going wrong. If you don't use EKS in your environment and EKS permissions get added, then someone's done something, either maliciously or accidentally, to get access to that environment. Another big part is patterns. I don't know if people in their day-to-day, if they don't do architecture, they might not think about how to build patterns for how services are adopted, but have patterns for how things like Terraform are used, what your network stack looks like, what your application stacks look like. If you're adopting RDS, what is the pattern of how you all are going to use it look like? So you define the networking, you define the guardrails, you define the IAM permissions. And then you can use things like Sentinel or SemGrep to basically enforce those rules when resources are provisioned. And that leads to those services being hardened out of the gate. So again, if you have rules that prevent you from having a public RDS, you're not going to have public RDSs unless someone goes in and starts messing with your resources. So it's really important to have those patterns documented, have the guardrails, and then turn that into infrastructure as code rules. And then I covered this quite a bit, but there's no way to have enough AppSec people or cloud security people to review all of your infrastructure as code deployments. We're always going to have more developers than security people. They move much faster than we can possibly read all their code. So you have to have automated code review in your pipelines to prevent these kind of things. Infrastructure as code has not been focused on as much in that way. I think people are getting a little more wise to it, but people haven't focused on it a huge amount, but it's definitely an important thing to do. And again, monitoring. You should monitor the IAM policies for your pipelines. You should monitor the resources that your pipelines provision. If you're only in US East 1 and US West 2, and you start seeing stuff in AP region and AWS, you know something's gone wrong. So you need to be monitoring the resources that these pipelines provision as well. Because the first thing that attackers are going to do is try to get out of an area that you're really monitoring well. So, final thoughts. Despite all the things I say about HashiCorp and Terraform, I'm actually a big fan of the tools. I just think you have to kind of go into it with your eyes wide open of the security issues. It's a great target for red teams or malicious actors, and if you're a blue teamer, it's also a really big opportunity to make a big difference in your cloud security environment. So definitely check it out. If you have any questions, I'll be around today, and also you can reach out. Glad to talk about it. Thanks.